Hi, my name is Jacqueline Graham, and this video will be discussing my research presentation on the structural and functional signature of action control, a research presentation which addresses the question, do individuals who procrastinate have a different brain and structure than proactive individuals? This question prompted our hypothesis. If we examine whether inter-individual differences in structure and functional resting state connectivity of specific brain regions, then we can predict the inter-individual variability of action control in humans. Before explaining my experiment, let's start by covering some background information. This experiment focuses specifically on the amygdala. The amygdala is the neuroanatomical hub for fear motivation behavior. To put simply, it's the fight-or-flight center of the brain. During fear conditioning, it encodes distinct memories that become critical in decision-making situations, because this is when the effective significance of a given behavior, stimulus, threat, or reward needs to be evaluated. During fear conditioning, the synaptic plasticity of the amygdala transforms sensory and somatosensory information of thalamic and cortical regions into a distinct fear memory. This memory then becomes especially important when put in decision-making situations, which is why the amygdala plays a critical role in action control. Action control can be defined by Cole's action control theory, which classifies action or stated-oriented individuals based on their response during situations in which action control is needed. Individuals differ in their ability to initiate self and emotional control mechanisms. These differences are classified as either action or state-oriented. Action-oriented can be defined as a person who is willing or likely to take practical action in order to deal with a problem. They are individuals associated with efficient use of self and emotional control process and goal-directed behavior. They are less influenced by possible consequences of an event and more resistant to cues that induce negative effects or stress. Action-oriented individuals can firmly focus on the task without being distracted by alternative actions. In contrast, a state-oriented individual can be defined as having an inability to initiate action. They are related to having difficulty of recruiting sufficient self and emotional control processes, thus hindering goal-directed behavior. They tend to remain in the undesirable emotional state and ruminate about an aversive event. These individuals can be characterized as procrastinators because they put off doing something, especially out of habitual carelessness, to postpone or delay needlessly. Now I will briefly discuss the materials and methods I used. This study was conducted with a total of 264 individuals between the ages of 18 and 35. As previously mentioned, we will be using Cole's action control theory, which is a test using 3 scales of action control. The first scale is the action orientation subsequent to failure versus preoccupation, or the AOF scale, followed by the AOD, or perspective and decision-related action orientation versus hesitation scale. Finally, action orientation during successful performance of activities versus volatility. This is an example of the questionnaire used to measure these 3 circumstances. For each item, a situation is briefly described, and the participant has to choose one of the 2 possible behaviors. Each response is coded as either action or state orientation. High values in action control indicate action orientation, and therefore advanced emotional and self-control mechanisms. To eliminate potential error, neuroticism, which is defined as the tendency towards anxiety, self-doubt, depression, shyness, and other negative feelings, is tested on the NEO personality test. This test sums the 48 items that constitute with the neuroticism scale. Next, the participants go through a series of brain imaging data. The anatomical imaging is useful for the identification of anatomical landmarks for the connectivity analysis. Resting state imaging is also acquired for the analysis of functional connectivity. fMRI resting state images are produced using echoplanar imaging. Now let's move on to the results. Our analysis yielded significant sex differences regarding action control. The AOF scores showed that females tended to be significantly less action-oriented than males, meaning that men are more capable of leaving negative emotions behind to start something new, whereas women tend to remain in the undesirable emotion state and ruminate about the aversive event. On the contrary, the ADO scores revealed that males turned out to be significantly less action-oriented when it comes to initiating actions than females were. Thus, men, who in this case tend to be more state-oriented, struggle to begin an intentional action. The AOP scores showed no significant sex differences. This means that male and females are equally able to maintain an action-oriented mindset as long as it is necessary to complete a task successfully without being distracted by alternative actions. Interestingly, we found a significant negative association only between decision-related action orientation. This result indicates that individuals who are state-oriented when it comes to initiating actions and therefore tend to hesitate or procrastinate show higher amygdala volume. This structure-function relationship showed a significant positive association indicating the high functional resting state connectivity between the amygdala and the DACC was related to higher action orientation in decision-related contexts, thus meaning that the amygdala guides the selection of actions by selecting desirable behaviors and inhibiting actions that lead to potentially unfavorable outcomes on the basis of previous experiences. Regarding action control, this could mean that individuals with a larger amygdala volume have learned from past mistakes and evaluate future actions from their possible consequences more extensively. Thus, in turn, this might lead to a greater concern and hesitation as observed in individuals with low AOD scores. Interestingly, it seems as if the amygdala is especially important when the results of a particular behavior are uncertain. This might explain why state-oriented individuals are especially vulnerable to the effects of uncontrolled outcomes and failures, whereas action-oriented individuals seem less affected by possible negative consequences. I also found a unique difference regarding functional resting state connectivity. Specifically, I found inter-individual differences related to action control were also related to differences in resting state connectivity between the amygdala and the dorsal angular cingulate cortex, or the DACC, a region of the brain that is known for the top-down regulation of the amygdala and various facets of self-control. This means that there is a permanent imbalance between both brain regions in favor of the amygdala, which correlates with a present inability to efficiently use psychological control processes, as it is seen in state orientation, which resulted in a low AOD. Overall, having a larger amygdala volume and less functional resting state connectivity of the amygdala and the DACC are associated with state orientation. One possible mechanism could be that higher amygdala volume leads to behavior that is more strongly motivated by fear. This in turn might lead to an increased worry about negative consequences, which again provokes hesitancy and postponement. Furthermore, the low functional coupling between the amygdala and the DACC might result in insufficient top-down regulation of negative emotions, which could result in an inadequate selection and implementation of actions in state-oriented individuals, which is why they resulted in a low AOD score. Up to this point, there have been various studies on the effects of inter-individual differences in action control. My research has shown that, among other things, inter-individual differences in action control moderate the interaction between executive functioning and self-controlled behavior. Additionally, previous research has shown that the differences in action control are associated with physical and mental health. My biggest critique on my results is that they are based on correlations between variables representing structural and functional brain features and the participants' action control, and therefore do not directly support causal inferences. There might be other factors that could contribute to the remaining variance in AOD. Even though the concurrent determination of both our neural and behavioral variables by a third factor cannot be entirely excluded, we demonstrated the specificity of our effects by comparison to neighboring brain areas, as well as considering various confounding variables that might mediate or generate such a relationship. In conclusion, my results are the first to show that variations in the anatomical architecture and network function of the amygdala are related to inter-individual differences in action orientation in decision-related contexts. Because AOD is central to various aspects of life, the insight into neurobiological basis is of high relevance. This is why further research studies should examine the hypothesis derived from this study and investigate whether the proposed neurobiological mechanisms are fixed or whether the brain stimulation or specific training can lead to changes at both the behavioral and neurobiological levels. Such findings would not only provide a causal explanation for the structure-function relationships I uncovered here, but also offer a possibility to shift individuals who have a low AOD score towards a more desirable, self-regulating behavior. And that concludes my presentation. Thank you for listening. All works used in this presentation are cited at the end of this video.